And this one says a fraction is any number that can be written in the form of a over b, where a and b are whole numbers and b is non-zero. So 1/2 is a fraction, 3/3 is a fraction, 6/5 is a fraction, 8/2 is a fraction.
Do you have that paper? I wasn't here.
I'll look for them. Is that it? Yeah. 8/2 is a fraction. I can't because it's a camera actually, but I'll do after that. So when you have a picture like this, what portion of the fraction is shaded? Or write the shaded area as a fraction. I don't know if you can see it. The shaded area is 3 boxes out of how many? 4. That's 3/4. Same thing as this one. 3 out of 4 boxes are shaded. 3 out of 4 boxes are shaded. When the top is lower than the bottom, 3/4, that's called proper fraction. The top is smaller than the bottom. If the top is larger than the bottom, it's called improper fraction. The top is always referred to as the numerator, and the bottom is always referred to as the denominator. So these are the ones, I can't make them bigger, but I'm going to actually go back and start writing now. So let's talk about fractions. And the first thing we're going to talk about fractions, change a mixed number to improper fraction. How do you change a mixed number to improper fraction? Again, let me clarify that a little bit there. If you're hungry, really hungry, you've been a week without eating, and you go to the Subway, you say, can I have 3 sandwiches or 3 subs, 3 grinders, whatever you want to call them, it depends where you are in the country, and you eat the first 2, and the third one you only eat 1/3 of the piece, 1/3 of the sub. How much did you eat? 2 and 1/3. Exactly. You ate 2 full ones and 1/3 of that one. That's known as a mixed number. Improper fraction, if you look at each one, there's 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. So you have 1, 2, 3, 4, 5, 6, 7. You ate 7/3 of a piece. 7/3. This is 3 threes plus 3 threes, that's 6 threes, plus 1 3, that's 7 threes. So that's called 7/3. So how do we change that number to make it look like that? That's what we're talking about, changing a mixed number to improper fraction. That's improper, the top is larger than the bottom. Mixed, improper. So this one is improper. This is a mixed number. And the math is really easy. The bottom stays the same. Notice we're going to take that number 2 and 1/3. We're going to change it. The bottom stays the same, 3. The top is going to be 3 times 2 or 2 times 3 plus this number. 3 times 2, 6 plus the 1, which is what? 7/3. That's how we change them. 5 and 2, 7. That's a mixed number. To change it to improper, the bottom stays the same. What's 5 times 7? Plus the 2, 37/7. Nine and 2/3. That'll be what? The bottom is the same. The top is going to be 3 times 9 plus the 2. What's 3 times 9? 27 plus 2? 29 over 3. 6 1/4. Bottom is the same. 4 times 6 plus the 1. What's 4 times 6? Plus 1? 25 over 4. Everyone get that? So that's how we change. So a lot of times we don't put that step here. We bypass that. 8 2/5. We usually go in our head. 5 times 8, 40 plus 2, 42 over 5. 7 2/9. 9 times 7, 63 plus 2, 65. So we do it in one step. Instead of going to that step, then to that one, we just do the math in our head. 9 times 7, 63, plus the 2, 65. Okay. How about the reverse? How do we change improper fraction to a mixed number? Change improper fraction to a mixed number. This is an improper fraction. 28 over 5. I want you to change that to a mixed number. Any idea? How? Divide them. 28 divided by 5, which is what? 5? 5 times 5? 25, and what's the remainder? This number that you see here, that goes right in the front. Now it's a fraction. This number here goes on the top, and this number goes on the bottom. 5 3/5. (24 over 7). Same thing. (24 divided by 7). You know what? Let me change it, because just both examples, both these numbers happens to be the same. Well, no, actually, well, let's make it 22, because I don't want to make sure the numbers are different. 22. Okay. What's 22 divided by 7? 3. 3 times 7? 21. What's the remainder? 1. So the answer, there's the 3 that goes in the front, and 1 out of 7. 3 1 7. Bless you. Let's try 50 over 9. 50 divided by 9. Could it be 5? 5 times 9 is what? 45. What's the remainder? 5. That number here goes in the front. And what's the remainder? 5 out of 9. So the answer, the quotient, goes in the front. The 3 goes in the front. The 5 goes in the front. This one on the top, that's on the bottom. Top, bottom, top, bottom. Now we're going to actually, the next one, equivalent fractions we're going to talk about. What's an equivalent fraction? If I wrote 2/3 and I said, give me a fraction that's equivalent to this, it's the same as this, same value. You can pick any number you want, except 0. Any number that you like. Somebody pick a number. 6, okay. Somebody picked a 6. If you multiply the top by 6 and the bottom by 6, it does not change your answer. So somebody decide to multiply them by 6. What's 2 times 6? 12. What's 3 times 6? 18. 2 over 3 is the same as 12 over 18. When you have a fraction, if you multiply the bottom by a number, you have to multiply the top by what? The same number. If you do that, the fraction doesn't change. The value stays the same. Again, if I take 2/3, when I said pick a number, I heard somebody say 5 there in the back there. So let's put a 5. 2 times 5, 10 over what? 15. This is equal to this, which is equal to this. All three are equal. 2 over 3 is the same as 12 over 18, is the same as 10 over 15. They're all equal. Multiplying a fraction by a number doesn't change it, doesn't make it not equal. As long as you multiply by the same number. If you multiply the bottom by 5 and the top by 7, then they are not equal. But as long as the same number, they are equal. To prove that, we're going to simplify them. Remember simplifying? Simplifying a fraction. Let's take the 10 over 15 and see if we can prove that's really 2 over 3. Again, we said if you multiply a fraction, the top by a number, you're going to multiply the bottom by the same number. What about if you divide the top by a number? You got to divide the bottom by what? The same number. Let's look at the 10 and the 5. Both of these numbers, you can divide them by what? By 5. If I divide this by 5, what do you have? 2. If you divide this by 5, what do you have? 3. Is that equal to 2/3? Yes, it is. Let's try the 12 over 18. Simplify that. Both of these fractions are divisible by what? 3, okay. I see a 6, but you're right. 3. Let's take a 3. What do we have? 4. What's 18 by 3? 6. Am I done simplifying? No. So just because we picked a 3, that doesn't mean it's wrong there. You just got to do another step. 4 and 6, you can divide them both by what? By 2 and by 2. And what do you know? It's 2/3. Now, if you chose a 6 to start with, what's 12 divided by 6? 2. What's 18 divided by 6? 3. Sometimes you don't see that big number, so it's okay to start with a small number and keep simplifying. What about if you can't simplify the fraction? I really want to know, are they equal? But before I do that, let me give you a couple of them to try simplifying here. So simplify 14 over 21. We'll start with that. And the next one we'll do 42 over 18. If it says simplify, notice this improper fraction. Leave it as improper fraction. If they want it to be a mixed number, they'll tell you, write the answer as a mixed number, especially in the math center. We specific how we want the answer. (42 over 18). 14 over 21. Let's look at the 14 over 21 first. It looks like both of these numbers divisible by what? By 7. By 7, this is what? 2. By 7, this is what? 3. That's 2/3. (42 over 18). Both are divisible by what? 6. Okay. By 6, this is what? 7. By 6, this is what? 3. Can I simplify it more?
Yeah.
To what?
2/3.
Well, they probably want the answer as improper. But you're right. If they said, give me the answer as a mixed number, that's a good answer. Unless they say change it to a mixed number, I will leave it like that. But if they want to make it a mixed number, you go 7 divided by 3. That's 2. 2 times 3 is 6. The remainder is 1. That's 2 and 1/3. But for this, that's probably the answer they wanted in. How do you know when you're taking a quiz which one they want it to be? You know in our math center all the exams are multiple choice. Look at your answers. They're not going to give you both. So if the answers look like a mixed number, choose that one. If the answers look like improper fraction, stay with that one. Don't do extra work if you don't have to. So take a peek at the answers. If you see them all improper fraction, don't divide them. Just leave it like this. If you see all the answers are mixed numbers, switch it. They will never give you both unless they said write the answer as a mixed number. Then to see if you know what a mixed number is, we'll give you that option. How about comparing fractions? Sometimes you look at two fractions, you want to know which one's bigger, which one's smaller. I'll show you two different ways of doing it. One of them probably not in the book. Comparing fractions. Okay. Let me take an example. 13 over 24 and 11 over 16. I want to know, are they equal? And if the answer is no, who is bigger? Who is smaller? Well, you can't say, well, 13 is bigger than 11. That means, oh, this one is bigger than that one. Because they have what? Different numbers in the bottom. If the numbers in the bottom were the same, then you're right. I could actually look at the top and see which one is bigger, and that will tell me what the correct answer is. But the numbers in the bottom are different. Is there a way I can make these numbers the same? How?
Multiply the 6, right? To get to
Yep. Multiply 6 by what?
4.
4. Sure. So if you multiply the bottom of this fraction by 4, you're going to multiply the top by 4. So what do we have now? 13 over 24. And the other one becomes what? 44 over 24. Since the bottom is the same, which one's bigger, the 44 or the 13? 44 is bigger. This is greater than. That's less than. 13 is less than 44. You all probably know the Pac-Man, the mouth points toward the bigger number. So 13 is less than 44, or another way of saying it, 44 is bigger than 13. Let's try another one. Well, I made this problem not bad because,
Excuse me, sir.
yes,
So that is the answer right there?
this is less than this. So if the question, which one is the smaller? That'll be the smaller. Which one is the larger? That'll be this one. So you just have to read the question and see, but this is smaller than that. As I said, I made this problem kind of easy. Why? Because this number is actually 24 is divisible by 6. You know 6 times 4 will make it that. But what about if I give you this problem? 7 over 15. And the next one is, box here, we're not sure, 4 over 9. Now we got a little problem. How can I find what the common denominator is? I need to make sure the number is the same. Remember from last class?
Least common multiple?
Least common multiples, absolutely. Take the 15, take the 9, do prime factorizations. 15 is what? 3 times 5, both are prime numbers. So it's 1, 3 and 1, 5. The 9 is what? 3 times 3, both prime numbers. 3 squared. And if you remember, we said the LCM, except in this case, because these numbers are called what? Denominators, the name will change now. It becomes what? LCD, least common denominator. But it's the same thing as the LCM for both these numbers. So the LCM last class was what? It's the multiplication of all the different factors. Well, let's look at it. What do you have for factors? 3 and 5. And each of them raised to its highest power. What is the highest power of 3? 2. What's 3 squared? 9 times 5? 45. So now I'm going to take both of these fractions that you see on the top, and I'm going to make the bottom 45 for both of them. We have to multiply the 15 by what to make it 45? By 3, right? And if you multiply the bottom by 3, you have to multiply the top by 3. What's 3 times 7? 21. The 9 goes into 45 how many times? 5. So you have to multiply the 9 by 5 to make it a 45. You multiply the top by 5. What's 4 times 5?
21.
Which number is bigger, the 21 or the 20? 21 is bigger than 20. So this is the larger number, that's the smaller number. I like this method because when we go to add and subtract fractions, that's what we have to do. So it's kind of building toward the next section. How do we add and subtract fractions when the numbers on the bottom are different? That's the process. But if you only want to compare which number is bigger, there's an easier way than all of this. I'll do the same problems here. If you just want to compare them without having to find the LCD, you do cross multiply. What's cross multiply? You multiply this number times that number, and you multiply this number times that number. Thirteen times 6. Is that a 78?
78.
The question is, where are you going to put the 78? On this side or on that side? You see the two numbers that you're multiplying? The 13 and the 6? Where's the top number of these two numbers?
13.
The 13, so you put the answer under it. Is it 78? We're going to multiply 24 times 11. The top number is the 11. We're going to put the answer here. What's 24 times 11? Is that 264? I think it's 264. Is the 78 bigger than the 264 or less than? Less than. That means this fraction is less than that.
How did you decide which side to put it on?
Where the top numbers are the two numbers you're multiplying. Notice the 13 and the 6. The top number is the 13. That's where that answer goes.
Okay.
So, excuse me, what about if the number there is less than 13?
Doesn't matter what that number is.
So always, that's
Cross multiply, always. 7 over 5. What was the other example we just finished doing? Was it 7 over 15? And the other number was what? 4 over 9? I'm going to multiply 7 times 9. 60 what? 3? And notice the 63, the top number is the 7, right? Out of these numbers, the 63 goes on this side. The next number, 15 times 4. 60, the top number is the 4. That's where the 60 goes. And which one's bigger, 63 or 60? 63. That means this fraction is bigger than that fraction. Remember earlier today when we did the 2/3 and we said that's the same as what? 12 over 18? I don't want to say it's equal. Let's see if they are equal. Let's compare them. What's 2 times 18? 36. The top number is the 2. That's where the 36 goes. 3 times 12. 36. And what do you notice about these two numbers? They are equal to each other. That means these two fractions are equal.
So does it mean that this is another way of doing?
That's the different way of doing the same problems. Just a different way. Instead of finding the common denominator. I like this method better because of the next section. But if my goal was just to find which one is bigger, if that was a question on the test, and I don't care about the other stuff, that's the quick way of getting to the answer.
That's comparing fractions.
Yep, comparing fractions. Just two different approaches. The book doesn't talk about this method. They just talk about this because they're laying the foundation for adding and subtracting fractions. And when you add and subtract, you want to go this direction.
So you can choose to do this.
You can choose either one of these, this or that.